So this video is about the definition of cosine of theta, sine of theta, and tangent of theta. Theta is a Greek letter that is often used for an angle. Like in algebra, we often use x for a variable. In trigonometry, we also often use theta as a variable for an angle. Almost all students learn SOHCAHTOA, which are ratios of sides of triangles. Those are technically not definitions of sine of theta, cosine of theta, and tangent theta. They're just given as ratios. And what we're going to go is from this idea of SOHCAHTOA that I'm going to assume that you remember to an actual definition. So consider a unit circle. That's a circle with a center at 0, 0 and a radius 1, 1. So this is a unit circle. So this is the important question in this video, and we want to keep referring to this question because the answer is the punchline here and ends up being the definition of cosine of theta and sine of theta at once. So the point 1, 0 is going to be rotated theta about the origin, and wherever it ends up, the question is, what are its coordinates? What are the coordinates of 1, 0 after it's been rotated theta? So now we see the point being rotated theta, and so the question is, what are the coordinates of this point right there? So if this is a right triangle that we've superimposed on this unit circle, and this is theta, then this is opposite, and at the bottom is adjacent, and the hypotenuse is 1, and that's going to help us out. Since the sine of theta is equal to the opposite over the hypotenuse, but the hypotenuse is 1, then opposite over hypotenuse becomes opposite over 1. And similarly, cosine of theta adjacent over hypotenuse becomes adjacent over 1. So now we can see that opposite is equal to the sine of theta and adjacent is equal to the cosine of theta. So what are the coordinates of this point? Well, you could think of right now the coordinates of this point as adjacent, comma, opposite, because you move to the right adjacent and then up opposite. But what are the coordinates of this point? Well, adjacent is equal to the cosine of theta, and opposite is equal to the sine of theta. So the coordinates of this point must be cosine of theta, comma, sine of theta. And that's one of the most important ideas in this chapter, that on the unit circle, when you take the point 1, 0 and rotate it theta, you end up at cosine theta, sine theta. And this is a definition that puts all of that together for any real number theta. And here's the important part. Theta doesn't have to be an angle in a triangle. It could be any angle. It could be an angle of 1,000,000 degrees. For any real number theta, cosine of theta, sine theta is the image of the point 1, 0 under or after a rotation of magnitude theta about the origin. And then notice tangent is opposite over adjacent, SOHCAHTOA. So since opposite is sine of theta and adjacent is cosine of theta, then tangent of theta is defined as sine of theta over cosine of theta. And that gives us our definitions of cosine of theta, sine theta, and tangent of theta.